Hi, I'm Charles Hoskinson, the Chief Executive Officer of Input Output Global, and I'm joined here today by a really amazing guest, Ben Goertzel. He is a world-famous AI researcher, and he started in a field near and dear to my heart, mathematics. And so why don't we start there? Ben, can you talk a little bit about the early days of your life, and why did you become a mathematician?
I was, the first memory I can dredge up from my cranium is watching Neil Armstrong walk on the moon, which I would have been like 2 years old or something, but it was so amazing to all the adults around me that it blew my mind at the time also, and that got me deep into science fiction. Watching the original Star Trek in its first run on TV with Kirk and Spock, all these alien civilizations, and even some robots, right? So from reading, analog magazine and various old potboiler science fiction novels from the 50s and 60s, it became clear to me that the whole human life that everyone around me was engaging in was a very, very small portion of reality in a broader sense, right? So there could be a whole physical universe out there with all these different star systems. There could be creatures 1 billion times smarter than human beings, and I somehow wanted to get out of the very limited mind space that everyone was in. So science becomes very interesting. Then mathematics starts to seem like the broadest possible way to explore the space of possible structures and dynamics. Like physics is great, and there's a lot of physical systems beyond what we encounter on Earth. On the other hand, in mathematics, you can formulate alternate physicses that don't exist in this universe, and topological structures with no geometry, right? So if you want to be open-ended and broaden your scope, mathematics in some senses seemed like the broadest you could do. Now, later in my life, I started to feel mathematics itself is somewhat limited in terms of the scope of realities it can explore, and there's other approaches that are also interesting. But I originally got fascinated by mathematics because it seemed a way to formalize and explore just alternate physical realities, alternate modes of thinking, just stuff way beyond the limitations of the human. Now, AGI was very interesting to me.
Hang on, we'll get to that.
Yeah.
So first, before mathematics, there was science fiction. So who did you like in the science fiction world? Was it like Isaac Asimov or Philip K. Dick?
TV is where it started with, right? It started with Star Trek because my dad sat me down to watch the original Star Trek whenever it came on, and then Space 1999 and a bunch of these shows. Although Star Trek, even at that age, I recognized was more interesting. And we saw a Kubrick movie like 2001, The Space Odyssey, which was very trippy, right? And this was a period when there was a lot of trippy people bouncing around my parents' social circle. Like my parents weren't big into psychedelics, but they certainly had friends who were. And then the end of 2001, A Space Odyssey has acid written all over it, right? So there was some singularitarian sort of thinking there, right? Like when you get beyond the human, whoa, like things are going way beyond our concepts of thought. In terms of science fiction authors, what I read then was probably the same as everyone else. And there was Asimov, there was Heinlein, there was Robert Silverberg, who got a little more into the mental and spiritual side of things. And at some point I discovered Olaf Stapledon with the Last and First Men and the Star Maker and these things, which is like a cosmic view of the intelligence of the universe. And it was a bit later, like teenage years, when I discovered Philip K. Dick and Stanislaw Lem, who probably were the two SF writers who had the deepest impact on me and really were thinking through the nature of reality and mind and intelligence in more of a profound way. And then later you get to Werner Vinge, Greg Egan, and the whole more modern canon, right? But in my early years, before I was able to read science papers, science fiction was the only place to find out about these things, right? And so that was probably all AI researchers in my generation got into it by science fiction, right? Because AI in industry and academia was a kind of obscure little corner. So science fiction was where you would hear about it, whereas now you read about it in the news. It's a whole different scenario, right?
Yeah. So how did that lens that you got with science fiction and having people in the social circle exploring altered forms of consciousness, how did those two things translate into your mathematical career?
Well,
as
my grandfather, my mother's father was a physical chemist. He worked with Linus Pauling and Hans Bethe and a bunch of these guys. So he was at U.S. Steel doing sort of material science stuff and X-ray diffraction work and so forth. So he tried to teach me quantum mechanics when I was like 6 or 7 years old, and it was exciting. Then I got pissed off because his own understanding was limited. Like he knew the old quantum mechanics, like Rutherford stuff, and scattering and so on. And then when you got into like standard model or even some of the Heisenberg stuff, my grandfather himself got confused. But he got me into thinking about physics and mathematics in a way that was interesting but quite confusing for a little kid. But you could see from even dipping your feet into quantum theory that it's like all about the math, because the words make no sense, right? So, and of course, my grandfather was an experimentalist, and it was clear from my discussions with him that he was much more of a nitty-gritty experimentalist than me, and my orientation was like, I want to understand what's really going on, which to my mind meant let's find the most elegant possible formalization of what's happening here. Right. Which wasn't so much his point of view, but although in hindsight, he taught me a lot about data analysis and like overfitting models and how hypotheses relate to data, which bored me to shit when I was young, because I just wanted to know like what are the core equations underlying everything. So I guess I just had an intrinsic bent of mind wherein, when given a bunch of confusing things like how the brain works or how X-ray scattering works, or how the body works, through either a curiosity or conceit or whatever it is, I want to find the most compact, elegant model of this phenomenon, no matter how abstract it is. You want to find a model that will fit in your working memory, where you can delude yourself you understand it, right? And mathematics seemed like the best tool for that. You're getting a simple crystallization of complex phenomena. Of course, I was also good at it, which helps, right? There's an intrinsic reward when you're a kid to playing with math when you have a facility for it.
Yeah, but ultimately that lens was evidently less than satisfying, because you didn't go on to become a professional mathematician.
I got a PhD in math. Well, yeah, I mean, I would say.
Well, what was the inflection point, like where your interest surpassed the field, and you didn't go narrow, but rather went broader?
I think, yeah, the reason I ended up majoring in math instead of physics or CS was I got bored with certain types of computer implementation. Like at that age, like implementing operating system or programming language stuff, it's just like, I know how this works, so I don't want to type in this much code. And physics lab classes were boring to me too. It was just too much fiddling with the machinery. Math, you just read a book, think, take a test, and it was kind of easy. So as a student, studying math was amazing, right? But then once you graduate, in my case it was a PhD, and you go on to doing stuff, right? Then I was very attracted to doing something huge and revolutionary. Right. And I sort of indexed I got my bachelor's degree at 18 and my PhD, I guess 21 or 22, right around my birthday there. And then I was looking at, well, what are the most amazing things I can do? I can make time travel work. I can, make nanotech or femtotech work. I can solve death and create human immortality. Or I could make superhuman thinking machines function. I mean, clearly there's some egomania or megalomania issue here, but these seem like really cool, exciting things that would inspire you to spend your whole life working really hard at them. When I look at all those things, somehow all of those things were more inspiring to me than proving math theorems, right? So for studying, math is just so interesting to study. But of course, you could spend 17 years like Andrew Wiles proving Fermat's last theorem. And that's very interesting. It's a lot of fun. But if you could spend those same 17 years like curing death, or making a backwards time travel machine, or making a superhuman thinking machine, somehow it seemed more compelling. And then you think about, okay, what if you make an AGI mathematician? Like that guy can prove Fermat's last theorem in 2 seconds instead of 17 years. And then wouldn't you feel like an idiot spending 17 years proving that theorem instead of coding the AGI that could prove that in 2 seconds, or creating a brain-computer interface that would let you participate in proving it in 2 seconds, and understanding theorems that can't even be compressed enough to fit into your human mind, right? So I mean that, and then when you enumerate all these amazing science fictional things, it seemed like, rightly or wrongly, it seemed like AGI was going to be the easiest one, just because the other things seem to need either very, very expensive machinery. Like you could, when I was 18 or something, I started doing a bunch of general relativity math about how if you could spin a football-shaped star, you get a line-shaped singularity, and if you fly near it, potentially you could go backwards in time. Very cool. On the other hand, there's some minor engineering difficulties there, right? And the nanotech, which now is becoming more and more feasible, still it requires very big, expensive machines. Biotech, like brain-computer interfacing or genomics for promoting longevity. I've done a lot of work now in machine learning for longevity, but you need to get permission to like poke people and cut open their heads and inject them with things. AGI seemed like could solve all these other problems if you made a benevolent AI that's smarter than you. B, potentially you can just sit down and type and it's done, right? Now, in a way that was very naive, because at that point I thought I could come up with a mode of creating AGI where I could just sit and type it myself without needing like an army of programmers and tens of thousands of GPUs or something. But it seemed like, well, maybe if you just have the right idea for the algorithm, just sit and code for 6 months and you've got the thinking machine. Now, 30 years later, I haven't created it yet, so perhaps in some way I was underestimating the magnitude of the problem.
So it seems to me there's a trend of wanting to avoid boundaries, and so you entered through mathematics, which is probably, and I agree, one of the most enjoyable topics to just self-study. You could just read for the rest of your life and discover things for the rest of your life.
And you'd only get through 1% of it.
Exactly, probably less than that. Especially with how much math has happened in the 20th century. And so then you say, hey, I'm going to go work on something that is so universal that if I was to achieve great progress in that, then this could be reapplied to achieve great progress in many things instead of just one thing. So you solve an AGI, you're also solving the time travel problem.
And then when I got
or the longevity problem.
older, I started thinking more about doing good for the world, right? And then you start to think, well, okay, my grandfather, who was a physical chemist, he got old and died, right? And my parents are in their mid-70s. They will get old and die. I myself could get old and die. And there's mental illness, there's all starving children and diseased children. I mean, there's all these issues in the world which could be solved by greater intelligence if that greater intelligence had a harmonious value system. So I think a little later in life, my motivation shifted just from the pure intellectual puzzle and the desire to do amazing, cool things to, well, there's a lot of really bad things going on this planet, along with really good things, and these could actually be cured, right? Like in the same way that smallpox is cured, and in the same way that electricity and airplanes solve fundamental problems, like having and antibiotics solve fundamental problems. I mean, having an AGI could create genuine abundance, and it could allow people to get root access over their own brains and minds and bodies. I mean, you can do so much good with an AGI, as well as being able to prove math theorems and solve physics beyond beyond the human scale. So that second sort of motivation kicked in slightly later in life. I got a bit more selfish-minded as a teenager when I was first getting into it.
So you came of age kind of in the middle between two revolutions of AI. So we had the Dartmouth guys in the 1950s, 1960s, and they're thinking neural networks. Oh, we'll have a thinking machine in 10 years, and of course that was a miserable failure.
Yeah.
But there was a lot of insight that came out of it. Then it kind of went into a winter for a bit, and now we're back into a world of intelligent agents and deep learning and these new techniques that have come out of industry, which are quite fertile and productive. But you kind of left the academy right in the middle of these two things.
You're right. So part of the reason that I didn't do a PhD in AI, although I was very interested in AI at that time, was that the field of AI at that time was preoccupied with things I thought were dead ends and very uninteresting, right? So, I mean, I wanted to do a PhD at one point on recurrent neural networks for time series prediction, and that was considered like verboten. No one liked that then, right? It was all these rule-based production expert system where you hand-coded
and now Wall
knowledge.
Street just loves that.
Yeah, now that's like an undergraduate course project that'd be funded by Morgan Stanley or something, right? But yeah, at the time, the AI field was really preoccupied with hard coding files of knowledge explicitly put into a weak sort of logic language by people. And it was clear to me you need a learning system. You need a complex, self-organizing, chaotic learning system that's engaged with the world. It's not about taking your knowledge and typing it out in logic expressions, right? And so the AI field just seemed to be going down the toilet to me, although, yeah, I loved reading books from the early stages in AI and general systems theory, and there was already a lot of interesting stuff written about the brain as a complex self-organizing system and neural networks and evolutionary systems for AI, but that wasn't really what the field, there was no funding for that. That wasn't what the field was preoccupied with. So I figured keep learning math, which is going to be useful for pretty much anything of any interest, and then try to do AI in my own direction, since the field was sort of dead ending. And then, yeah, AI has become more popular and successful, but I still think it's pursuing kind of stuff that's a dead end from the AGI perspective.
Yeah. So let's get into that in a bit. So first, we know the influences on the sci-fi side and the family side. So who are the AI influences that kind of sculpted the way that you thought about intelligence and AI and how to pursue these ends?
My thinking about AI and how the mind works did not come out of the AI field, really. Partly because the AI field was off in what I felt it was an uninteresting direction. So I was heavily influenced by philosophy of mind, probably more than by AI. So I mean, I loved the later Nietzsche's writings, where he was sort of looking at how does the mind construct the world in itself by pattern recognition. I mean, all there is morphology and the will to power, right? It's like patterns recognized in patterns trying to extend themselves more over the world. And Charles Peirce, an American philosopher who invented quantifier logic, but he had a whole philosophy of mind, again, as sort of self-organizing pattern recognition systems. And I was heavily into nonlinear dynamics and chaos theory and sort of self-organizing systems. Then what was known in the 50s, 60s as general systems theory, right? So you had Ashby, von Verdelenfly, Ilya Prigogine, all these guys looking at how complex systems in general self-organize and build up emergent structures. So I was much more thinking in those directions than in terms of what the AI field was doing. I do remember there was a book by John Andreas, who was a professor at University of Canterbury in New Zealand, where he was trying to build what would now be called a probabilistic reinforcement learning system that would learn to would learn to give intelligent responses just by being trained from feedback, from interacting with people, and that was cool. That had an influence on me. That was in the mid '80s or something. His PhD student, John Cleary, I got to know in the early '90s when I was a professor at Waikato University. And John Cleary later worked for my AI company, WebMind, in the late '90s. and his students formed WebMind's New Zealand office at that point. So there was a sort of thread of probabilistic sort of reinforcement learning based on experience that I encountered early on. And John Holland's early stuff on genetic algorithms, which was back to 1970s. I mean, that was quite interesting and influential because again, he was looking at complex self-organizing systems that intelligence sort of bubbles up out of, right? And so, and some of the early neural network was like that too, before neural nets became more supervised learning focused, as has happened in the sort of the big data era. Right?
Yeah, it seems like you're being vindicated by recent trends with this approach.
I will be vindicated much more in the next few years. We're just seeing the first inklings of it now.
So let's get into that. There's projects like NEL, for example, like Never-Ending Language Learning at CMU, and obviously Google has DeepMind stuff and so forth. But you founded something called SingularityNET, and this, I guess, is your philosophy on how one would achieve over time an AGI approach.
So there's a couple interesting projects that I've founded related to AGI. SingularityNET, which is a decentralized blockchain-based AI platform, is one of them, and OpenCog, which is a straightforward attempt to build an AGI, is another one of them. And actually the interpenetration and the sort of fusing of the OpenCog AGI system and design and the SingularityNET decentralized AI platform, I think we can bring those two together in a very productive way via porting SingularityNET onto the Cardano platform that you and your colleagues have created. And this is something that I think can have a quite profound effect in terms of accelerating progress toward AGI. So let me break that down a little bit. So SingularityNET, it's not really a cognitive architecture or an AI system. SingularityNET is a decentralized platform that allows a lot of different AIs created by different people doing a lot of different things to all collaborate and cooperate together to solve.
So it's like problems. A fertile environment for them to live within.
Yeah, I mean it's a multi-agent system which is sort of tuned for the AI agents in the multi-agent SingularityNET is a multi-agent system which is tuned to work well for agents that are doing AI of various sorts, right? So you can, in the very simple sense, SingularityNET is just a protocol for different AIs to communicate and cooperate with each other, right? So two AIs in the network, they can exchange identities, they can pay each other, they can ask each other for things, and they can respond to those requests. They can swap data, or they can reference data sets. They can decide to cooperate in a certain way. So SingularityNET is a communication protocol between multiple agents that may live anywhere on the internet, and they may be owned by anyone. They may be open or closed, but it's designed specifically to allow AI agents to communicate and cooperate in various ways. And one of the things you can do with this decentralized protocol is to create a marketplace. So you could actually create multiple marketplaces on the same protocol. So we have a SingularityNET AI marketplace now, which has a bunch of different AIs providing various services, some of which are pretty nitty-gritty, like there's a song splitter app with a back-end service that takes music and splits it into multiple stems or tracks. There's face recognition AIs. There's some things that are more abstract, like AI agents that recognize patterns in graphs. These different AIs, they live in the SingularityNET decentralized platform, and people can get those services by paying in a cryptographic token or paying using fiat currency, which is then converted on the back end to a cryptographic token. But that sort of scratches the surface, right? Because where it gets really interesting is you don't just want to have a marketplace where people are paying for services and the AIs are providing them. I mean that's good, and it's good to have that decentralized and not owned by a big tech company. But where things get really interesting is when the AIs on the platform are providing services to one another, right? Or are cooperating together, like, well, I can't do this on my own, but if we work together, I can do this. Maybe I outsource some work to you, you outsource some work to me, and then cooperatively we can fulfill this. So you have assemblages of AIs that are dynamically cobbling themselves together based on the requirements of the moment.
And this is unsupervised interaction.
It's unsupervised.
So you give a goal to the system or an objective, and then it has to figure out how is it going to work within that environment, including working with other agents that it has no knowledge of other than its capabilities.
Right, and that figuring out is done by agents in the network, right? So right now the agents running in the network are really kind of simple, and most of them are solving problems on their own that are posed to them by users or customers, although there's some cases where you have an AI agent that then outsources some work to another AI agent. But the objective is to get more swarm intelligence happening, right? Where the intelligence is in the combination of multiple agents. And I think that the current blockchain infrastructure underlying SingularityNET, which is based on the Ethereum blockchain and the Solidity scripting language, I mean, this has been great in that it let us get where we are now and build an actual blockchain-based decentralized AI network and marketplace. On the other hand, various limitations in the Ethereum blockchain they're going to hold us back from getting to the next step that we need to get to with SingularityNET and really creating a SingularityNET that's capable of this sort of self-organizing emergent swarm AI, which is really part of our original mandate.
So let's dig a little deeper into that. This concept of incentives and form can force evolution towards a desired goal. And the other thing I want to add into that concept is this idea of mechanical turking. So right now we're thinking of AI in terms of agents that are programmed and they're non-human, but every now and then you do augment human intelligence. And so is the point of SingularityNET just to be strictly automated and strictly non-human agents, or is there a place in this framework for the mechanical Turk concept?
So at the moment, SingularityNET agents are just AIs, they're automated agents. On the other hand, the SingularityNET framework is very flexible, right? So I mean, anything that has an API can be integrated with the SingularityNET daemon in a container, and it can participate with the rest of the SingularityNET network. Now that could be a software program. It could be like a micro brain in a vat. It could be.
So in essence, we almost have like a reverse Turing test.
Yeah, I mean, it could be a pigeon pecking on the touch screen, or it could be human mechanical Turks, of course.
Yeah. Right. So what intrigues me most about this concept, though, is this idea that we can create challenge problems to force the evolution of the system. So I go to SingularityNET and say, I have this problem. Can you solve it? And if the network can't figure out a solution to it, then there's the question of, well, what incentive do I have to provide for the network to figure out a way to produce that, either an external actor or the network from within to create a solution to that?
Yeah, that's right.
Yeah.
So once you have a diverse pool of AIs in the system and a diverse pool of AI developers who are working on putting new AI in the system, and ultimately AI algorithms that are learning new AI algorithms, right?
Right.
Then once you put those incentives in, then that can stimulate all this self-organizing activity among AIs that create and tune AIs, and among human developers who see a gap there and put a new AI in there, and then that can result in a system that will fulfill the goal that you had suggested.
Right. And then that becomes part of the commons. And so the system continues to evolve over time. It's a really elegant approach.
So I think there's going to be a needed shift to agent-based thinking on the part of developers, right? So you'll need AI developers to start thinking not what can my software do on its own, or not what script can I write to best leverage these libraries and data sets, but what agent can I best write that will achieve valuable goals in interactive dynamic cooperation with other agents, right? And most programmers don't think that way right now. And SingularityNET, along with other allied tools, may catalyze that shift in perspective in the development world.
Right. And then there's one other thing. The lifeblood of these systems is data. So, where do you get the data sets from to train these things and to operate on and so forth? How does that interface with the SingularityNET concept?
Yeah, so here, actually, we have a partnership with Ocean Protocol, which is another blockchain project that was founded by my friend Trent McConaughey. And what Ocean has done is they have built like a token-based marketplace for data, and they also have a cool framework for compute to data, where someone has a data set they don't want to let off their servers. You can like send AI in a container to crunch on the data there and send out only a certain approved type of result, or just keep the result local there. Then the AI vaporizes itself. So I think the SingularityNET sort of API marketplace and the Ocean Protocol data marketplace can interoperate quite interestingly. Now, of course, Ocean is only one data marketplace among many out there, but it's an example of what could be done in that direction.
Right. So you're creating a marketplace of saying you can provide solutions, you can incentivize the development of solutions, the system can autonomously come up with new solutions and evolve itself to do more interesting things. And you can also come in it from a different side and become a data provider.
You're going to have a decentralized network of decentralized networks, right? So SingularityNET has been focused on sort of the API of APIs and the AIs that are providing the intelligent processing. Now, Ocean Protocol is one token ecosystem for data. Now, there's a project called Rejuve, which is a spin-off of SingularityNET, and that's creating a sort of tokenized data marketplace specifically for medical data, and largely medical data oriented toward longevity, right? So you, if you're someone who wants to live forever or a really long time, you may upload some of your medical data into the Rejuve data commons. You get some Rejuve tokens in exchange, and then you can get compensated if anyone makes use of your medical data for something. So again, Rejuve and Ocean are two like tokenized ecosystems aimed at properly compensating and incentivizing contribution of data, and SingularityNET then needs to interoperate with these, right? And I know you've focused a lot on interoperation of different token ecosystems in Cardano also, right? So I think that's going to be very important. There doesn't need to be one token to rule them all, right? I mean, the beauty of tokenomics is that you can sculpt the logic of a certain token to incentivize things in a certain aspect. So you would expect there will be multiple tokens crafted for different purposes that all
have to
interoperate with each other, and tokens designed to incentivize contribution of different types of data, I think will have a valuable role to play here.
Yeah, and I think that's probably the biggest misconception that novices in the blockchain industry have, is this concept of maximalism, where they say, oh, my blockchain or my token or my ecosystem should be able to do everything and all other systems are scams or competitors. The reality is so much more nuanced, where you have a framework, and for that framework to be able to be successful, it has to talk to hundreds of services. And the point of Cardano is to act as like a connecting tissue in that sense, so it can help that coordination of those different economic activities.
I mean, if you just want to use blockchain to make more efficient copy of one token to rule them all, you end up with e-dollar and e-ruble and e-RMB.
Exactly,
right?
They're going to be much better at this game than us.
Yeah, well, of course, because they have the guns, they have the army, right? So, I mean, I think that's ultimately is a losing game, right? Because in the end, fiat currency will become blockchain-based and will become digital, and it will become more efficient, and its use will be mandated by a bunch of jackbooted thugs and armies and drones with machine guns bolted onto them. On the other hand, making an array of different tokens that are customized to serve particular functions and incentivize particular things in particular ways. I mean, this is something that governments are too stupid to do, and they're too general purpose to do. And this is something that an evolving entrepreneurial ecosystem is ideally suited for, right?
Yeah. So, what excites you most about Cardano? What about the project is compatible with the way you think?
Yeah. there's a number of things that excite me about Cardano. And so the simplest thing that we can get from porting SingularityNET to Cardano, by which we mean initially putting a significant chunk of SingularityNET AGI tokens onto Cardano. So what I want to do is make SingularityNET platform infrastructure multi-chain. I mean, we had that in our minds from the very beginning. So right now it's all on Ethereum, which was expedient at first, but it doesn't have to be all on one blockchain. I mean, maybe it will be optimal for it to be all on some other blockchain. But for starters, we want to make SingularityNET infrastructure multi-chain. So some of the AGI token supply remains on Ethereum, and some migrates to Cardano, and then how much remains on Ethereum and how much goes to Cardano, you know, that's sort of for the community and the market to decide, right? I mean, if the Cardano portion works much better, right, then everything should migrate there. If it turns out the Ethereum portion is more useful for some purposes, and the Cardano portion is more useful for some purposes, then so be it, right? So
it's almost like hosting infrastructure. You know, Rackspace versus Amazon or Azure. These are ultimately cost and quality decisions that you make for your customer experience.
And these are both moving targets, right? Like at this exact moment, Ethereum is very frustrating to deal with, right? Like it's insanely slow and expensive to do simple things, but I mean that's a moving target. There's Ethereum 2.0. It may be that it becomes great at something. I don't want to write it off, right? So I think the simplest thing that we can get from moving a big chunk of Singularity under Cardano is just a less inefficient and overpriced blockchain infrastructure, right? And I mean that's obviously is critical to us creating a SingularityNET that fulfills our goals and becomes a decentralized intelligent system. I mean, the whole process of designing SingularityNET infrastructure was a matter of trying to artfully work around the slowness and expensiveness of Ethereum, which has just gotten worse and worse. But there's limits to how much you can do there, right? So we need a faster, cheaper blockchain. Cardano, I think, can be that, but there are other things that could be that also, right? So I think there's also deeper aspects of the Cardano vision and infrastructure that are interesting to me and that synergize with our SingularityNET code now and with our SingularityNET aspirations going forward. So I think that there's a big focus on formal verification in the Cardano world, and as a mathematician, that's very interesting to me, right? Like I would love to see automated theorem provers running in SingularityNET and leveraging the SingularityNET decentralized AI network. I'd love to see these decentralized AI-based automated theorem provers put to work, you know, verifying smart contracts running on Cardano and helping verify Cardano infrastructure code, right? So there's a number of steps to get to where this is really being done, like on a efficient and large scale basis. But it's fairly clear how one would do that. Actually, it's just there's a number of steps to get there.
Yeah, and actually, this is one of the most exciting parts about these types of partnerships for us, because your needs help evolve our ecosystem. So when we look to the future, we say, okay, well, we've built a great blockchain, but what ancillary technology do we need to put into the system for it to be useful at a global scale for many different utilities? We say, okay, should we do heavy investment in homomorphic encryption or into zero-knowledge proofs or to multi-party computation, whatever? We look to our partners and we say, well, what do you guys need? Where do you want to go? What type of marketplaces do you want to be involved in? And how can we help build this technology together and make that consumable infrastructure to grow with you?
Yeah. So the next thing is something we've been discussing a while, actually. So the part of this SingularityNET mandate and vision in the first place was something we called the API of APIs. And what that means is, I mean, each AI agent in the SingularityNET has a certain API, a certain programming interface that describes what it can do, what data it wants to look at, what kind of requests it can fulfill, what kind of responses it can give. But this is going to be very heterogeneous. There's many different kinds of AI. There's neural networks, there's evolutionary systems, there's logic engines, there's ant systems, there's a huge list of AI paradigms, there's a huge list of problems that AIs from these different paradigms can solve. And this is totally a moving target because the AI field is advancing so rapidly. So the API of APIs, that's, what system does the SingularityNET protocol as a whole use to manage all the different APIs that different AIs are wanting to use to talk to each other and to talk to end users, right? So to support the API of APIs, this sort of meta API that SingularityNET needs, we need a way for an AI to describe to end users or to other AIs. You need an AI to describe, what kind of data it wants, what kinds of problems it can solve, what kind of results it can dispense, and to describe some of the properties of what it can do. So you need an AI to sort of describe itself and its properties in a fairly abstract description language that other AIs can understand, and is quite flexible and can deal with the rapidly evolving nature of AI and all the allied technologies, right? And so this leads you down some funky rabbit holes of programming language design, and it leads you toward functional programming languages for describing input, output, and properties of AIs. Now, of course, one could build a functional programming layer for describing AI's input, outputs, and properties totally separately from the blockchain layer, right? On the other hand, if you have a blockchain layer which speaks functional programming language already, that gives you more opportunities for sort of integrating this API of APIs more deeply with the underlying blockchain protocol. And this has large advantages when you want to do things in a secure yet scalable way. So you mentioned homomorphic encryption, there's multi-party computing. So if you want to make this sort of scalable, decentralized, secure computing work for AI, you actually need the blockchain infrastructure, which is tied into the encryption code. You need that to understand the description language that describes what the AIs are doing, right? So that's, again, it's a couple steps down the road, but if you want this decentralized emergent swarm AI to operate in a way that respects data sovereignty and is secure by design, then ultimately you need a blockchain that has functional programming infrastructure, and Cardano is pretty much it, where that's involved at the moment.
Right. Yeah, just some corollaries to that, there's this concept of trusted third parties, and what we almost always do in the world of cryptography or whenever we build these complex distributed systems is we get about 80-90% of the way there, and then there's some hard problem that we can't quite figure out in the distributed sense, so they say, we'll just go trust Bob to take care of that. He'll be the trusted escrow, the middleman. And when you're talking about swarm intelligence and you have all these autonomous agents that are trying to work with each other, you can't, in a general sense, admit these trusted third parties in the same way. So you need to have protocols that actually eschew them. They get rid of these trusted third parties. And that requires miracles of cryptography, like homomorphic encryption, but it also requires real good concepts of identity at the base layer as well. So for example, with Cardano, we have a product called Prism, which is all about DIDs and identity management. And it's not just about identity for individuals like human beings, but also institutions or intelligent agents inside a swarm network. You can identify them with first-class citizenship the same way you would identify a human actor. Now, to the functional programming side, one of the things that was really important to me was the ability to admit DSLs in our system easily. Because you have all these domains, whether it be healthcare, supply chain, or AI, and each and every person in those domains, they're brilliant within those domains, but to actually replicate their needs in a general programming language introduces so much overhead and complexity and semantical issues.
Well, if you want to get formal verification
to actually
work, I mean, doing it on the Turing complete language with the way that most programmers are going to use that language, ultimately that's solvable, but you're getting toward an AGI hard problem.
It's like doing math where you have to go back to piano arithmetic for every proof.
Yeah, right. So if you have a DSL for your specific domain, then formal verification becomes a lot closer to tractable, and then you have security by design, which helps a real lot with getting scalable adoption in the commercial world.
So let's look to the future. So let's say 10 years, 15 years into the future, what's your vision for how Singularity and other projects of yours can grow towards getting us to an AGI? What would be the ideal scenario?
Well, this brings us back to the OpenCog architecture, right? So right now, OpenCog is an AGI, a proto-AGI architecture, and we're using OpenCog to make some agents running inside the SingularityNET platform. But the OpenCog architecture and the SingularityNET platform architecture, they're not really commingled. They're layered, right? But there's the opportunity to commingle them for tremendous mutual benefit once we've added a functional programming-based API of APIs and much greater efficiency to the SingularityNET level. So the way OpenCog works, to oversimplify greatly, is there's a weighted labeled metagraph knowledge store called the atom space. So it's nodes and links. Mm-hmm. It's not strictly a graph because there's links that span more than 2 nodes. There's links that point to links. There's links that point to whole subgraphs. But it's a generalized graph or metagraph that stores all the knowledge the AI system has. And it's big. It has to be distributed across many machines. And then you have multiple different AI algorithms that act cooperatively on this big distributed metagraph. So for example, you have a probabilistic logic engine that looks at knowledge and tries to extrapolate to new knowledge. You have a pattern miner that just scans the whole metagraph to find surprising patterns, right? So if you have sensory knowledge, like audio data or video data, you have neural nets that recognize patterns in those data, and the neural nets are then symbolized by nodes in the knowledge graph, and you work it out so that composition of different neural nets is sort of morphed into composition of the symbolic nodes matching those neural nets in the hypergraph. So you have activation spreading through this distributed metagraph to indicate the flow of attention, right? So it's in some ways similar to what was called a blackboard architecture back in the 1980s in AI, actually, where you had the vision where there's a knowledge blackboard, and there's a bunch of different AI agents that are collectively writing on the blackboard and erasing on the blackboard, and they're solving a problem together through their collective activity on the shared blackboard. And what you need there is what I'd call cognitive synergy among the different agents, wherein when one AI gets stuck because it hits some combinatorial explosion or something, then the other AIs can help it get unstuck. What that requires is the different AIs have visibility into each other's intermediate state so that they can really understand how and where each other got stuck. So we spent literally decades working out how to get different AIs, say logic engine, neural systems, evolutionary learning systems, activation spreading systems, how to get different AI systems to cooperate together in dynamically updating a common knowledge hypergraph in a way that makes semantic sense and is reasonably scalable, and that, which is quite hard, right? Because logic, program learning, neural nets, all these things have different semantic languages, and so you need to be translating among these semantic languages reasonably fast, and in a way that makes sense from all their points of view. So OpenCog attempts to solve that problem, and we've used it behind the Sophia robot in some cases. We've used it a lot for analyzing biomedical data and making hypotheses, regarding how and why different genomic patterns or different drugs will cause different biological phenotypes. So what we're looking at now is rewriting that whole system from scratch. Like the algorithms are good, the philosophy is good, the representations are good, the infrastructure is not good enough, right? So
you have a superpower now, which is you have a space to manage state. You have this blockchain component.
Exactly. So the new version of OpenCog called OpenCog Hyperon, we're looking at, making the knowledge metagraph much more scalable as a distributed system, and then we're developing a new programming language for scripting the AI algorithms, which will be a gradual, dependently typed language. And the goal there is to get a language in which the core algorithms we need regarding our AGI are as concise as possible, partly for convenience of the human programmers, but also to support reflective meta-learning. Like, you need the AI to be able to learn and understand its own algorithms. And for that, you need the AI's own algorithms to be as compactly expressible as possible in the AI's own representation language, right? So we're developing this new Atomese programming language, and we're making a new version of this distributed hypergraph knowledge store. And we're just getting started with this. Now, if we tie this back into SingularityNET, I mean, if the SingularityNET platform were efficient enough, right, then what you could do, you could have this atom space, this weighted labeled hypergraph knowledge store, be a knowledge resource for agents in the SingularityNET network. And you could have the different AI algorithms in OpenCog, say a logic engine or a neural system or an evolutionary system. You could have them be different agents in SingularityNET. And then what we're now doing sort of inside the C++ runtime of OpenCog, that could be done within the decentralized playground of SingularityNET, right? And of course, to have really efficient interaction, you'd have a bunch of SingularityNET agents that are living on the same server farm. But then there are some things where you don't need such efficient interaction. It could be among remote SingularityNET agents. But to do that, to sort of blow out what's now going on inside OpenCog into the whole SingularityNET protocol, I mean, you need way more efficient interaction in the SingularityNET protocol,
right.
and you also need a more abstract description language on the SingularityNET layer. So I think the work that we're going to do in terms of bringing SingularityNET into Cardano, this will enable a lot of interesting things. I mean, it will enable a more commercially viable SingularityNET AI marketplace. It will allow all sorts of experimentation with Swarm AI and such on SingularityNET platform, but it will also lay the ground for taking what's now happening inside OpenCog out into SingularityNET marketplace, which has a lot of interesting implications. I mean, among other things, it opens the door for the first AGI, I mean, assuming OpenCog is a workable framework for AGI, right. It opens the door for the first AGI to be controlled and owned by a decentralized network of parties.
Right.
So that, like, one guy coded and owns the logic engine, another guy coded and owns the neural engine, and the decentralized knowledge hypergraph was coded and owned by different people with different security restrictions, and the emergent general intelligence in the whole network is not owned or known or understood by any one person, right? It's really an open-ended intelligence in a profound way.
As a counterbalance to these closed frameworks that are being built by large corporations,
yeah,
like Google and Microsoft.
Absolutely. So this gets into sort of the AGI ethics, right? Like, if you believe, as I do, that historically we're on the verge of creating superhuman general intelligence. I mean, we could be as little as 3 or 4 years away from there. I think we could pull it off quite rapidly if we had, a focused team funded just to work on building AGI. But even if we're 20 or 30 years away, I mean, it's a blip on the time span of human history. So we're really close to creating superhuman AGI. On the other hand, whether that superhuman AGI will be benevolently disposed toward humanity or indifferent toward us and considering us more like we consider the ants in the ground underneath our construction site, right? That is less certain, and it may be determined to some extent by how we get to that AGI. Like, what goals is it fulfilling? Who is it serving as it evolves? And this is where the decentralized, democratically governed ecosystem, I think, has profound ethical advantages to the large corporate / government modality of working on the AI.
Right. And also there's just a humanitarian question of should this be owned by one or by the many, because it has benefit to the many. And it makes more sense to make this as open as possible. Two more questions and then we'll wrap up. The first one is right now we're talking a lot about the technology and capabilities and how to implement and so forth. There's another way of looking at these systems, which is what type of problems can these systems solve?
Yeah.
So for example, one thing that I'm very keen to explore is that I would love to mechanize the entire US code, all the federal laws, the state laws, these types of things, because I would like to be able to ask, is the act I'm about to take legal or not? And there's been some lawyer computer scientists at various different schools like Notre Dame and Stanford and other places who've started interesting things, like one created a language called Akkadian, and he had something called the Hammurabi Project, and he was trying to systematically codify all of US law in machine understandable ways. So at what point would I be able to go and as an input and a goal into SingularityNET say, hey, I would like this network to go and just figure out how US law works, and then I'd like the system to grow to a point where I can ask a legal question to it in a sufficiently ambiguity-free way, and it can give me an answer.
One way to think about the transition from narrow AI, which is what we have now, we have AIs that carry out highly specific problems. They solve highly specific problems based on highly specific data sets they've been given for training or highly specific rules they've been fed. One way to think about the transition between the narrow AI ecosystem to the AGI ecosystem, where you have true human level thinking machines, is through what I call narrow AGI, which sounds oxymoronic, but what I mean by a narrow AGI is a system that displays increasing levels of general intelligence but focused in a certain vertical area, right? So like think of like a human math genius who has hardcore Asperger's syndrome, and they're really smart at proving math theorems, but they're really dumb at a lot of other things, right? So you could have a system that is, say, really good at coordinating activities in a smart city, or really good at analyzing biomedical data, or really good at driving cars, and that does transfer knowledge and generalize and even think laterally and creatively within that domain, but still is weak on general intelligence outside that domain. So I think we're now in a position where we can start building sort of narrow AGI systems in key vertical markets.
Is the problem I proposed an example of a narrow AGI?
I think it could be. It's not one that I've worked on. So we've worked a bunch on narrow AGI in the biomedical domain, where you have questions like personalized medicine, right? Like which people with breast cancer will be helped by which combination of drugs based on their genomic information and why. And for these people who weren't helped by any drug, like what research direction might you take to find a drug that will cure them, right? So this needs some creative hypothesis making. The data is scant, it needs a lot of transfer learning. So that's one domain where we've been doing narrow AI, verging on narrow AGI, both in OpenCog and in SingularityNET, right? And smart cities is another one where you need to connect together AIs, sort of dealing with different kinds of data in a smart city, but you need some AGI to integrate all those different kinds of data within a common knowledge representation. So in neither of those cases is it like you're just throwing the data and the problem at the AI and pushing go, and the AI spits out the answer, right? Well, so with law, I think it's the same way. Like that would certainly be
it's
interesting it would be interesting to approach that, but it would require a lot of domain-specific gathering of training data sets and training of models, as well as some sort of proto-AGI code that aims to generalize from what those narrow AIs are figuring out.
Yeah, so this is an interesting emergent property of having an open system where you actually have a mechanical Turkish element. We think of Mechanical Turk as simple task, but it could be as well as I'm just an AI programmer, and I see these interesting challenge problems, and I know if someone's willing to pay.
I can tell you what you would need to do to solve that problem. The Mechanical Turks are going to be highly trained paralegals in this case. Like what you would need to do is the following. You could take, right now, you could take existing legal code and case law, and you could have paralegals translated into simplified controlled English like the average person can understand, right?
Right.
And once you have translated the legal code and the case law into simple controlled English, we then have AI that can read that and they can translate it into an abstract representation in OpenCog's knowledge base. And then you have a fun AI problem where you can recognize patterns and do reasoning. And the interesting thing is, after you had your paralegals do enough Mechanical Turk translation of legal code and case law into controlled English, then you have a supervised learning problem, right? Then you want to train a GPT-3 type AI, but with way fewer parameters, to carry out that translation of legal prose into controlled English for things outside that training data set, and then Bob's your uncle, as the Australians would say, right? But the Mechanical Turk there, though, this is paralegals translating at least tens of thousands of pages of legal code into simplified English.
Into like a reCAPTCHA type situation, but obviously significantly more involved.
because it's sort of the same problem as translating legal code and case law into something that someone with a middle school grasp of English can understand, right? If you've done that, then with the current state of AI, the AI can translate that English into structured knowledge, and then it can do all sorts of reasoning on it, and it becomes very, very interesting. But right now, the AI cannot translate legalese prose into structured English. There's too many commas and parentheses and cross-sentential references and stuff that our NLP doesn't deal with. But yeah, in Singular. Now, if I were to take this on just as a project right now, which is very interesting, we would just you would hire paralegals to do that, and you would train models, and you would do this within the OpenCog system, right? And that would be quite doable. That would be a beautiful AI startup, right? That would be a fun thing to do. And you could then, of course, deploy that AI lawyer on SingularityNET as an agent. Now, the more decentralized way to do it, of course, would be, you have the paralegals themselves are agents on SingularityNET, and the process that's summoning up those paralegals is an agent on SingularityNET, and then the system that is taking the simplified English that the paralegals produced and translating it into structured knowledge that goes into OpenCog admin space. That's another agent owned by another guy. And then the reasoning engine that does legal reasoning based on the legal knowledge put into the admin space, that's another AI agent, right? Owned by another guy or another startup or whatever it is. And so then the whole process is done by different entities in that decentralized network. And that is completely feasible. It requires that could be done now using the current infrastructure, because there's nothing in there that requires fast-paced real-time interaction. What that would require is more traction, right? That would require a robust human ecosystem using this platform.
Let's talk about that. So and this is the final point in question, one of the other things about Cardano that's not as well known at the moment, but it's a huge pillar of the project, is the Voltaire component of the project. So this is the governance layer of Cardano. And we kind of break it down into the who pays and who decides side of things. And right now, as the network is running, about $6 million worth of ADA is put into a treasury account. So $72 million a year at current market price for decentralized funding of projects. And what we decided to do is we're trying to structure Voltaire in a way that there's a strong innovation management component to it. So the problem I just gave is an example where I'd say, I have a challenge, something like, I want to codify all of US law in a way that machines can operate and give me meaningful answers about. Well, then there's a discussion of, well, how to do that, how much does it cost, how many companies need to be involved, and so forth. And this is really the crux of the Voltaire framework. It's a collection of tools to help that process along, to go from an unstructured open challenge to an actual plan of attack with funding behind it. So for example, SingularityNET's future evolutions or OpenCog's future evolutions could actually run through this process and get funding for it. So as your application evolves, not only does it provide use and utility, if you make a good argument of how enhancing that use and utility is beneficial to the Cardano ecosystem, you can now get funding for it. The coolest part is it's funding for the open domain. There's no notion of intellectual property or patents or big company owning these things. So the outcome of this process is the evolution of all of the tech for everyone to the benefit of the entire ecosystem. So I guess the question I have for you is, given that we have these capabilities and we're working together, what would be the most successful collaboration in your mind? If you had to say you made the decision, come to Cardano, and you look back at that decision 5 years in the future, what types of things had to have happened for you to say that that was a good decision, a successful collaboration in your mind?
So there are two separate but coupled high-level goals that I have in mind with SingularityNET and with the SingularityNET Cardano partnership. So one is making breakthrough progress toward general intelligence, right? Which is the closest thing to my heart as a researcher. So I mean, if our technology developments aligned, so that through integrating SingularityNET with Cardano, coupled with our ongoing work on OpenCog Hyperon, if that came out so that we could create AGI on this decentralized platform, I mean, then I don't care if we got the other goals done, right? I mean, then of course, that will be a tremendous financial windfall for everyone who's contributed, but it also obsoletes much of the current money economy also, right? So that substantial progress toward AGI is a foremost thing in my mind. The other thing that's highly critical and that obviously ties into that is getting real traction in the world for decentralized AI. I mean, now almost all AI is done within a few large tech companies and working closely with some government agencies. And the vision of SingularityNET, as well as other projects in the blockchain meets AI space, I mean, the vision is that most AI developers and most AI users don't need to deal with big tech companies, right? The vision is that most AI should be done in a more peer-to-peer way with individual developers or small groups creating AI agents that cooperate with each other and serve users who access AI through this decentralized network. Now, right now, we're starting to get a little traction on SingularityNET, but it's teeny tiny sliver of what big tech is doing, right? So, I mean, we need to get meaningful traction so that at least a non-trivial plurality of the world's AI processing is being done in the decentralized ecosystem rather than by big tech. And I think even if it were like 10% of the world's AI or 20% of the world's AI was on decentralized networks, I mean, that would be amazing, right? Because that would mean that there was an alternative and there was a real competitor, and it would constrain what big tech was able to do because there's this decentralized AI alternative out there. I mean, just as having Linux out there as an open source OS, even if it's not 100% of the market, it's there, right? And that completely constrained.
And it also changes the competitive dynamics because they don't need to build their own AI group. They could just use the open standard, just like a company can use Linux.
Well, that's right. So, I mean, one possibility, of course, is the decentralized open approach to AI just overtakes the whole AI industry.
Right.
But even if that doesn't happen and we just become a significant player with a decent plurality of the global AI market, I mean, that completely shifts everything toward democratization, and it shifts things toward globalization in a profound way also. Like what you're seeing now is a new nationalistic tribalism in regard to technology, right? Which completely goes against how science and technology innovation work, and I think it also goes against what we need for the emergence of ethical AGI that's evolving for the good of humanity as a whole. So again, Linux and open source, they all counteract that, and having AI done in an open, decentralized network, that counteracts that as well. And it's not like you're going to stop US, Chinese, Russian, and other governments from wanting to do nationalistic things with data and AI or with operating systems. I mean, they're going to until the singularity obsoletes nation states, right? On the other hand, the more of AI processing and data and human brilliance that you can put into decentralized AI networks that don't respect national borders by design, right? You know, the more you put into these networks, the better off you're going to be. So we're going to work toward AGI and toward emergent AGI in decentralized networks, and we're going to work toward getting more and more traction for decentralized AI as a whole, you know, including both narrow AI and AGI. And by doing the AGI R&D in the SingularityNET meets Cardano network and getting more narrow AI traction in important vertical markets, be it medicine, finance, smart cities, law, whatever, getting this narrow AI into the platform, then you're creating a condition where in which narrow AGI applications in key vertical markets are gonna emerge in this SingularityNET meets Cardano network.
It's going to be a fun future.
So. As long as Trump doesn't blow us all up first somehow, right?
We had to throw that in.
Yeah. So, it'll be edited out anyway. So.
We'll leave it in. So thank you so much for coming in. I really do appreciate it. And this is an example of when people say Cardano needs partners, Cardano needs projects. It's not the quantity of projects matters. It's the quality of the projects and what they seek to do and what these projects do to the platforms that they're hosted on. For me, to answer the question that I asked you, what's my hope out of the partnership and the growth of this over the next 3 to 5 years? Your needs force very difficult business and technical requirements on the capabilities of Cardano as a platform. And there's no reason to go and pursue these unless there's a commercial partner, a platform, an application that wants that. Much like CryptoKitties kind of forces the discussion of scalability on Ethereum, similarly SingularityNET forces significantly more involved requirements on us. So it makes our system better. It makes me a better CEO. It makes Cardano a better protocol by having these things in our orbit and collaborating with them and asking questions of how do we actually service these needs and allow you to achieve the goals that you have. So this has been a great conversation.
Yeah, that's a very important way of looking at it. And I think in SingularityNET as well, people in our community are constantly asking me, well, Ethereum's too slow. Ethereum's too expensive. Why don't you move on to a faster blockchain? And of course, there's something to that. On the other hand, it's a very narrow way of looking at it.
Exactly.
Right? And what we need is not just a faster blockchain. We need a framework that will let us take the proto-AGI code now inside the OpenCog system and split it out across a decentralized global network so we get a general intelligent global brain that respects, you know, data sovereignty and democratization.
Right.
And that's about more than just a faster blockchain, right?
Exactly. And I cannot wait to have these conversations throughout the years, especially as we get into data privacy and how to mine that. Well, there's never enough time. Thank you everyone for listening. This has been an interview with Ben and Charles, talking a bit about SingularityNET and Cardano and some great ideas. And I hope to do many more of these with many other partners. Thank you so much for listening. And until next time, have a nice day.
Thanks for a great conversation.
Cheers.